Welcome to Norton Chemistry. Today we're going to be answering some exam questions on aromatic compounds for OCR A Level Chemistry. Feel free to go through ahead of me and answer the exam questions, and then as I go through them you can check your answers. I'll link the questions in the video description. So yeah, let's go. So question 1. Compounds B and C, shown below, are unsaturated hydrocarbons containing 9 carbon atoms. Compound B reacts with chlorine at room temperature, but compound C requires the presence of a halogen carrier. So room temperature and halogen carrier are the keywords there. We want to circle our functional groups in our molecules. So in compound B, we've got an alkene functional group, characterized by the carbon-carbon double bond. And in compound C, we've got a benzene functional group, characterized by that circle, and yeah, we know what a benzene group looks like. And it also says down here that the organic compounds in both reactions react with chlorine in a 1:1 molar ratio. So this is most important for compound C because we know that there's not going to be multi-substitution, it's just going to be a single mono-substitution. So let's just go ahead and draw out the basic structures. So for compound B, straight away we can identify that there's not going to be the alkene group is going to be removed by electrophilic substitution. So we'll just draw our side chains on here and go ahead and just add our chlorine molecules at those positions where the double bond was. Then for compound C, we're going to have our benzene group and we're going to have our side chains and we're going to have a mono substitution through the mechanism of electrophilic substitution because it is a benzene group and it requires a halogen carrier. So part 2, explain the relative resistance to chlorination of compound C compared with compound B. So compound C, as we said before, is benzene, and benzene has a delocalized pi system where it has 6 delocalized electrons spread over 6 carbon atoms, whereas compound B we know is an alkene. Alkenes have localized electron density here between the plane of the carbon atoms. So there's only 4 electrons spread over 2 carbon atoms. A higher electron density means that the functional group is more polarizes neighboring molecules more readily and is more susceptible to electrophilic attack. So we'd set out our answer like we'd start with compound C has a benzene group which has delocalized electron density in its pi system. And we could also mention that 6 electrons are spread or even delocalized over all 6 carbon atoms. And then we could talk about compound B is an alkene, so has localized electron density where 4 electrons, actually you could mention it as greater localized electron density, less or lower. 4 electrons are spread over only 2 carbon atoms in the carbon-carbon double bond. And then to get the final mark, you would say something like compound C polarizes neighboring molecules / is less susceptible to electrophilic attack than compound less readily than compound B. Outline the mechanism for the reaction of compound C with chlorine. So compound C is the compound with the benzene ring. So we know that the mechanism is going to be electrophilic substitution. And the question also says, show the role of a halogen carrier. We've got 5 marks available for this question. So we'll start with our how we make the electrophile, which is going to be using the halogen carrier and the chlorine. So we're going to react chlorine with the we could say aluminium chloride or iron chloride, whichever one floats your boat, and that's going to react to make Cl plus electrophile. It needs to be a strong electrophile because benzene and the delocalized pi system, obviously, as we've seen above, has a low electron density. So a weak electrophile, such as that, doesn't have a great enough charge to accept electrons from the pi system, which is the role of electrophiles. And we're also going to make AlCl4-, which we're going to use later in our mechanism. So step 2 is our actual reaction of our electrophile with the benzene, and make sure that you check your structures carefully so we know that we've got our 3 branches here and our 3 methyl groups, and we need our electrophile, and then our electrons are going to come out of the pi system. We're going to use curly arrows, of course, and that's not a very good line. They're going to attack, well, the electrophile is going to accept the electrons from the benzene ring, which is the definition of an electrophile. I'll just write that down. Electrophile, electron pair acceptor. And our next step, we're going to form a horseshoe shape because we've lost 2 electrons from this pi system, and we need to make sure this covers at least 4 sides of the ring, because 4 electrons, 1 electron for each side. So I'll go for something like that, and there's going to be a positive charge as we've lost electrons from the system. And don't forget your chains, and we need to draw our chlorine group here, and also we'll have a hydrogen group which we're going to lose to the pi system. But we're just going the electrons in this bond are going to attack the positive charge, and we're going to lose that. That will form a hydrogen ion. So this is our final step of this section of the mechanism. So we just leave our chlorine group on there, and then our side chains and our H plus on. And then step 3, reform our catalyst, because obviously that's the role of catalysts. They increase the rate of reaction, decrease the activation energy, and are regenerated. So we're going to make AlCl3 and HCl as that's our side product, which you'd include in your overall equation, but obviously you wouldn't include your catalyst at all. Okay, so thanks for watching. Make sure you check out my other videos for more exam question run-throughs, advice on how to revise for A-level chemistry to help you get an A star.